Now, we learned about CORS in the last lecture. Now let me show you how it affects our post request. So I'll use my post button to also add an event listener there. Click. Like this. And in there, I'll also use the fetch method to send a fetch request to the same URL as before, but it ends with /post because I'm targeting this URL here, which is just post, not posts. So if you named this differently, you should of course use your path. Here, since it will be a post request, I need to pass a JavaScript object as a second argument, which allows me to set some options. Specifically, I want to set the method to post here, to send a post request. And then I will copy that code from up there for handling the response so that I can extract the data or log a potential error. If I now clear that and I hit create post, I get post created successfully, but if we inspect the post object, we see that the title and content are missing. Now that makes a lot of sense because we didn't send that data. Instead, on the post request in the client, we also want to set a body object, and that object will hold the title, code pen post, and content created via CodePen, whatever you want. If I clear that and now I click that button again, I still don't see that here. Now on the server side, nothing goes wrong here. But actually, on the server side, if I would go to my controller and I would log title and content here, or use the Node debugger to see their values, if we log that and I click create post, then we see that undefined gets logged here. So we are not able to extract that data. And the reason for that can be found if we go to the network tab and have a look at this post request that was sent. There, in the request headers, we see that the content type was text plain. And that is the problem. It should be application JSON. But we also see that the request payload was not JSON data, which in the end is just text, but in a special format, but that it was a JavaScript object, which just can't be sent, or which can't be handled. So there are two things we need to do. First of all, on the body, I will call JSON stringify, which is a method provided by default by JavaScript. It will take a JavaScript object and convert it to JSON. We can see that immediately if I click create post again and we inspect that request, the payload now is indeed text in the JSON format. But we need to tell the server that our content type is of type application JSON, and therefore, besides setting the body, on the client, I'll also add headers, or one header, the content type header, content-type, which is application/JSON. And now with that, if I click create post again, now in the created post we see title and content, because now that data is sent and extracted correctly because we send it in the right format and we inform the server about the content type. Now this also allows me to demonstrate what happens if I would comment out this header here, the access control allow headers header on the server side. If I save after commenting this out and I try to create a post again, I fail because I'm not allowed to set content type. I do allow this by adding this header on the server side. So this is how you communicate between client and server. Of course, the client code differs depending on the client you're using. This is JavaScript code using the fetch API. There are different ways of sending asynchronous requests. For example, you can send AJAX requests through libraries like Axios. And if you're building a mobile app, you might have a totally different object or helper methods for sending such requests in Android, in Swift, and so on. So this client code differs. This is the JavaScript code using the fetch API. The server-side code does not really differ. You want to make sure your clients can communicate and that everything works just fine there. Now, before I conclude this though, one more word about the post request we're sending with this click. You might see that I actually have two requests being sent. The second one is our post request. What is the first request? If we have a look at it, we see the response is just post, okay? The headers are interesting though. We can see that in the general part, the method here is options. And that is this last method I showed on the slide earlier. I mentioned it would be sent automatically by the browser and also, for example, by many mobile app clients. What is the idea behind options? The browser simply goes ahead and checks whether the request you plan to send, which is a post request, that is why here in the request headers, which are generated automatically by the browser, it checks for the post request. It checks if that will be allowed. Otherwise, it will throw an error. This is simply a mechanism the browser and many other clients use, and there's not too much you need to do to make this work. It just works out of the box. You just want to make sure that you set the right course headers here. You can add options to the allowed methods, but as you see, it was able to make this request before. This is not really something you need to do, but you can do it. But the important thing is that you are not confused by that extra request. It's simply a mechanism the browser uses to see if the next request, which it wants to do, the post request, will succeed, if it is allowed. And this is all I want to tell you about CORS and client-server communication for now.